The goal for today is for you to really be able to connect graphs and tables and equations to sort of bring all of what we've been working on with proportional relationships together. And then maybe we'll even be able to look at the idea that there are two graphs for every proportional relationship. So to do that, we're going to start with this problem here where I've got a proportional relationship that I need to plot and then complete the table and write an equation about. And so if I'm given this point here at point A, 10, 4, that means I'm going to come over 10 and then up 4, and then we'll label that point A. And again, because we know this is a proportional relationship, as long as we have one point, it's going to run through the origin here at 0, 0, and so I can draw a line through there. So that's the first thing, is just graphing it, and now I have this nice little graph that I can look at. The other thing I'm going to start looking at is where else in this graph do I see it cross, like does my line cross this grid? And I notice right here at 5, 2, it also crosses that, the grid crosses that line, or the line crosses that grid. So what's valuable about that is that just with this point right here, 10, 4, I can fill in some of my table right here. And so what this table is saying is this is my X column, and this is my Y column, my Y values there. And then this is where we're going to look at that Y divided by X. And if you remember, this should be our constant of proportionality. And so we can come over here to this point that they gave us. When X equals 10, we know that the resulting value here is 4. The other one that I notice is a whole number is this 5 and 2. And so I can come over to where X equals 5 and fill this one in. So one way I can find that constant of proportionality is simply to take the Y value and put it over the X value and simplify if I need to. Well, I don't actually need to simplify that any further, and so I know that my constant of proportionality is 2/5. And so that's a nice thing. I like to find that right away when I've got my table of values, and then my third column I can kind of add in is that constant of proportionality. And if I look down here at this last one down here, I can do my Y over my X, 4 divided by 10, and I can simplify that down to 2/5 as well. So that's a great way we can kind of start doing this. And I'm going to skip down to this problem right here before I start completing any more of these parts in this table. Because when I look at this table, it says complete the table with the coordinates of points on your graph. Use a fraction to represent any value that's not a whole number. I could start by estimating, but if I want to be really precise, I can actually use this proportion, my equation for my proportion, and this constant of proportionality to help me be really specific and evaluate it. So we know that a proportional relationship always follows that Y equals KX. And so K is our constant of proportionality, which we just identified as that number right there. And so I can know that I could write my equation as Y equals 2/5 times X. And so what that says is if I know the X coordinate, I can then plug it in here and then evaluate it, and I will get the resulting Y coordinate. So what this might look like is maybe I'll do a little table like this. If I wanted to know this number here for, well actually I already know 0, it goes through 0, 0, right? So I know that that coordinate right there is 0, 0. If I wanted to know what the resulting the value is of Y when X equals 1, well, I can remember that that is my constant of proportionality, right? That's going to be 2/5. But if I didn't remember that, I can use the trick where I'm going to do for everything else, where I simply plug in the value for X into my equation. And so I can write Y equals 2/5 times 1. Well, that equals 2/5. Beautiful. So I already knew that. That's beautiful. I'm going to come back to this column over here in a minute. If I wanted to continue down in this table, I can do the same thing. I'm going to use my Y equals KX, but since I know my K is 2/5, I'm going to write Y equals 2/5 times my X value, which is 2. So I'm going to plug that in here. And now I'm just multiplying a fraction, right? Because 2 times 2 is 4. And then I have this is essentially over 1, right? Because any whole number is over 1. And so that equals 4/5. And so my resulting Y value here is 4/5. And if I take a look at my graph, that's about right. You know, I can see that that's exactly kind of where it crossed. I might have estimated 4/5, but maybe I might have estimated 3/4 or something. So that's why I like this strategy when you are faced with sort of integers, numbers that aren't integers, because you might make an error in your estimation and maybe miss some of the patterns that might emerge as you go through this. So let's do the third number here. So when x equals 3, so again, I'm going to plug into my equation y equals kx. My k value is 2/5. I'm going to multiply that times 3. So 2 times 3 is 6, and this is over 1. 5 times 1 is 5. And I'm starting to notice a pattern that I have 2, 4, 6, and I'm increasing by 2 every time. So that makes me think that this one down here for 4 is going to be 8/5. And let's see if we can evaluate it by rewriting that equation by plugging in 4. 2 times 4 is in fact 8/5. So my pattern prediction is correct. And that's why I think this problem is a really good one when it says keep it as a fraction, because we start seeing the pattern. And if I were to make this into a mixed number or a decimal, I might not see that pattern. And so graphing proportional relationships is begging you to keep things in fraction form. And if we were to think about, well, suddenly you're like, oh wait, but there's a 2 there. Well, if I think about what that really was, well, that was 10 divided by 5, right, in that same pattern. Oh, that equals 2. And so now I don't even have to continue evaluating. I have enough of this pattern. I can sort of make sense of that repeated reasoning and think that, okay, 2, 4, 6, 8, 10. This is going to be 12/5. This is going to be 14/5, 16/5, 18/5. Oh, no, don't panic, right? This was really 20/5 equals 4. So our pattern has continued in that same way. So now looking at this y over x situation, I now need to say, okay, I know that it's going to be my constant of proportionality, but I can also sort of prove that that works by actually evaluating what it asks me to do, which is take my y coordinate and divide it by my x coordinate. So that's what I'll do, just a couple of these over here, and we'll see if a similar pattern emerges. So I've got the y divided by x. I'm going to take my y coordinate, which is this one, 2/5 divided by 1. And the reason I chose to write it this way is because when you try to write like 2/5 divided by, you're like, well, I don't even know what that means. Freak out. But if I write it this way, I can remember that multiplying by the reciprocal is same as dividing. So I could rewrite this division problem as 2/5 times 1. Oh, that's just 2/5. Dreamy, which is like, whoa, that's what I wanted it to be. Yes. Great. So let's look at the second one here, where we've got what's this one? 4/5 divided by 2. And so I'm not going to panic. I'm going to remember that dividing fractions is the same as multiplying by the reciprocal. So I need to flip this second fraction here. Well, what's 2/1 as a reciprocal of that? That's going to be times 1/2. And so now I get 4/10. If I think, okay, so 4/10, ooh, I can simplify that down into 2/5. Beautiful. So let's just kind of keep our eye on what happens to this pattern. I noticed that this one doubled and this one also doubled, because I also think I added 2 or I added 5 here. So let's just keep an eye on what happens, and that might help us figure in some of the later problems. So let's do y divided by x again. And so now I'm looking at this column here. So I have 6/5 divided by 3, which is the same as 6/5 times the reciprocal of 3, which is 1/3. And so now I get 6/15. Ooh, okay, interesting pattern starting to emerge. I have 2, 4, 6, 5, 10, 15. That's a cool pattern that I'm starting to wonder about. I can think that maybe 2, 4, 6, this should be 8/5, 10, 15, 20. We'll do one more and see if we get that same number. Again, I can think about, okay, I can simplify this fraction, and if I simplify it down, I can think, ooh, that's 2 times 3 and 3 times 5. Ooh, I can pull that 3 out of both, and so I'm going to get 2/5, which is what we're predicting. We just want to confirm with our math that that pattern is actually accurate. So let's do one more and see if we get that. We think it's going to be 8/20 based on this pattern we see, but let's evaluate it, and then maybe we can fill in from there. So I want to take 8/5 divided by 4. And so that is the same as 8/5 times 1/4, excuse me. And so, ooh, yay, I got 8/20. That's what I wanted. And again, if I simplify that down, I can think, okay, how many times does 4 go into this, or does 2 go into this? Oh, it goes in there 4 times. and that goes into the 5 times. Ooh, I can simplify this. If I keep kind of doing that same pattern, I'm going to get down to 2/5. So I could continue on the same pattern. I can go 2, 4, 6, 8, 10, 12. I notice it's the same number here. Oops, that's a 14. And I have a 16. This is an 18, and this would be a 20. And then if I look down here, I'm increasing by 5. 5 or 10, 15, 20, 25. This is going to be 30. This is going to be 35. This is going to be 40, this is going to be 45, and this would be 50. And so if we were to simplify all these down, we would see that same constant of proportionality would emerge every time. So big takeaways from this portion of the lesson is that if you have that 1 point on your graph, then you can graph the whole thing because you know that a proportional relationship runs through 0, 0. And then you can use that to plug things into your table. Start by finding places where the graph crosses the coordinate grid on whole numbers, and then using your constant of proportionality that you find by putting your y divided by your x. And so I can just do y divided by x to get my constant of proportionality. Then I can use that to evaluate for individual x coordinates. I could also have, if they had given me my y coordinates, I could have plugged the resulting y coordinate in here and evaluated for x. That could have been a thing I could have done. The other thing, just to sort of connect with this, remember there's 2 reciprocals. I mean, there's 2 constants of proportionalities for each equation. And so if I wanted to solve this for x, well, in order to get this equation, I need to get the x by itself. So I need to multiply by 5, 2, like this. And so I might say that x equals 5, 2 over or times y, 5 halves times y. And so just to kind of keep that in the back of your brain, that you can always sort of go the reciprocal if you want to know the x instead of the y, is the reciprocal proportional or reciprocal constant of proportionality is there as well. And so our graph would look slightly different if we had graphed that out. So those are our big takeaways. And then just a few notes to copy down into your notes, and then you can head to the practice problems.